We're now going to solve for x with removing a common factor and the case substitution method. Okay, so with removing a common factor, what you need to understand is it's similar to when you are factorizing. So if I had x squared plus 2x equals 0, for example, I can see that there's an x here that is common, and I can remove that common factor, x into x plus 2 equals 0, and then I'll have x equal 0 or x equals -2. We're going to use that same kind of thinking. I hope you guys are realizing that when you're doing maths, a lot of the concepts are built on previous concepts. So when you're studying and you're having an issue with a certain concept, sometimes it may be good to just track back a grade back, a few terms back, and get that core understanding so you can then do the later on work. So when we're looking at this, we can take out 3 to the x as a common factor. We're working with the sum right here. We can take out 3 to the x as a common factor, and we're left with 4 plus 1 equals 15. 3 to the x into 5 equals 15. 3 to the x equals 3. And we're left with x equals 1. As simple as that. As long as you can see how to remove the common factor, you will be able to do the later steps. Let's move on to a slightly more challenging question. And here we're going to be working with this question right here. If we look, what can we see is our common factor? And it's 2 to the power x. But we have other things in our exponent. So let's rewrite it where they're just terms without any extra addition or subtraction in our exponent. So we'll have 2 to the x times 2 to the minus 2 plus 2 to 2 to the x minus 2 plus 2 to the x equals 84. Now, we then going to see that we have an x to the minus 2. So we're going to do the same thing for that as well. You can do this in one step. You don't even need to do the step if you're more familiar. But as you're learning, take it step by step and do these extra steps. Later on, you can start skipping some steps when your accuracy is high. It's more important to be accurate than save time. So in matric, it is important to be able to do both. So practice, practice, practice. If you look at all these terms, right? So what I'm going to do is highlight each term. Let's get a nice highlighter here. See, this right here is one term. Oh, this highlighter is too dark. Let's use this light green. This right here is one term. This, let's pick another nice color. It's blue here. This right here is another term. And then this right here is another term. I want you guys to notice that when there is a multiplication, they count as one term. But once you have an addition and subtraction between the terms, the next term is starting. So note how to look when the next term is starting. So if we look at each of these terms, what is common? 2 to the power x. So I have 2 to the power x into 4 plus, there's a plus sign here, plus 1 over 4, which is the same as 2 to the minus 2, plus 1 equals 84. And then if we look here, this will be 2 to the x into, you put this into your calculator. So we'll go 4 plus 1 over 4 plus 1, and that will give us 21 over 4 is equal to 84. We times in 2 to the power x by 21 over 4, so we're going to divide 84 by 21 over 4. So we're going to go into our calculator. First, let's write down 2 to the power x equals, and then we're going to go 84 divided by this 21 over 4, we'll get 16. Then we can go equals, we'll press shift fact into our calculator. So we'll have 16 shift fact, and we'll get 2 to the power 4. So we have 2 to the x equals 2 to the power 4, and then we have x equals 4. Like bases, we can drop the exponents. Going to look at E. Now, in E, there's something that's different, and that's that this x right here, okay, it has a 2 in front of it. If you look at our other questions, here and here and here and here, the x has a coefficient of 1. There's a 1 in front of it. So when there's a 2 in front of it, or when it's not 1, we're going to use the k substitution method. And when working in the method, the criteria is that this coefficient here is double the next coefficient. So let's go into this question. We're going to do the same process as the last one, where we separate the terms first. So we have 3 to the 2x minus 2 times 3 to the 2 times 3 to the x plus 81 equals 0. Now let's simplify this a bit more. So I'll have 3 to the 2x minus 9 times 2, which is 18 times 3 to the x plus 81 equals 0. Okay, so let's go into this. This is a new technique that you're going to do. You're going to let the term that is half, you can see this x here, this part of this term, that is half this right here. It's half the exponent component of it. So the one that is half, we're going to let it be k. So we're going to say let 3 to the x equal k. So now I'm going to have k squared. Now you may be asking, how did I get this k squared? Because if I have k squared, it actually equals this 3 to the x to the power 2. We're doing it like that. And since this right here is k, we're putting it in there. So now, since we understand that, we can say minus 18k plus 81 equals 0. We now can factorize this, and we'll have, so when I do my factorization, I like to put the brackets first. I put k here, I put k here, then I say, okay, 9 and 9, it's going to be a minus and a minus, so then k equals 9. Okay, we got this, we're done. No, we're not done. The question is not to solve for k. The question is to solve for x. So I'm going to substitute what we let k be back in here. So I'm going to have 3 to the x equals 9. And now I'm going to have 3 to the x equals 3 squared, and then x equals 2. Let's move on to the next question. We're now going to do g, and in g we have this 4x and this 2x. So what my first instinct here is, let me convert this 4, and this 4 can be written as 2 to the 2 to the x plus 4 times 2 to the x minus 5 equals 0. Now this isn't a term we can work with. Before, it wasn't in a way we could work with it. Let me write this x a bit neater. So now it is in a way we can work with it. So we'll have 2 to the 2x plus 4 times 2 to the x minus 5 equals 0. And now since we have this middle term that's half the first term, we can say let 2 to the x equal k. And in doing so, this is now going to change to k squared plus 4k minus 5 equals 0. I'm going to open my brackets, equal 0. I'm going to have 5. I'm going to have 1. I'm going to have k, and k, what's this? Plus 5 minus 1. I'm going to have k equals 1, or k equals negative 5. Now for the k equals 1, we're going to say 2 to the power x equals 1. We know that 1 is the same as 2 to the power 0, so we know that x equals 0. For this k equals negative 5, we're going to have no solution. Now you may be wondering, why is this no solution? And let's look at this for a second. If I have 2 to the power x equals negative 5, is there any number that I can put to this positive number as a power to get negative 5? No, there isn't. Because if I put 2 to a negative, let's say 1, it only becomes a fraction. It doesn't change it from a positive to a negative. If I put 2 to a positive number, I'm just going to get a bigger positive number, so it doesn't work. If I were to put a fraction, so let's say I put 2 to the half, I am just going to get the square root of 2, which isn't going to give me a negative number. So there's no real solution here. Let's move on to some challenges.